So we are recording. This is Lecture 8, Algebra 1, and I am switching over to Karen.
Good morning, everybody. Hope my microphone's not making a thud noise. Sorry, moving it around a little bit. Anyway, okay, I'm going to start off. Oh, I got to click show my screen. Sorry. There we go. It'll be coming up shortly. I want to start off today. We're going to look at some systems of linear equations. I wanted to discuss the types of solutions you're going to get. You guys have a little experience. Most of you have started working on this now. And so we'll do a few types of problems that kind of line up with some of the stuff you're going to see. So it'll help you. Let me get that pulled up on a separate screen. So I'm getting a lot of questions about, let me see, what's the number? I'm trying to find the number that was confusing a lot of people. Let's see. Anybody want to shoot out there? Go ahead in the question box and tell me what was the one that was confusing you guys so much yesterday. Okay, yes, thank you. That's a good one. And we're talking about Lecture 8, right? The one due today. Okay, that sounds good. I got you, Megan. Okay, so we'll come to that. Let's get warmed up, and then we'll look at that. Okay, let's see. I may have to look at those, Megan. I'm gonna have to let me get to that. I'm gonna get to systems, just the raw topic though. Okay, let me get to this, and then we'll look at those if we can. If I don't have time for that in this webinar, I will attack that this afternoon. I wanted to tell everybody, and those of you watching the recording, that I have now my virtual office is ready for you guys to join me. On Tuesdays and Thursdays after the webinar, I will be in my virtual office. It's going to be in view.com. I'm going to put a link after the webinar in the general forum for you guys. It's View, spelled V-Y-E-W. So it's pretty interesting. I have had quite a few people join me there to get some help, and we got a lot of stuff done. So it seems like it's going to be a good thing for when you guys really are in need of some help. So anyway, virtual office is in effect, so you guys join me there. Look for the link in the general forum, and what's going to happen is save that link, because that office is going to be open for you guys all the time. Okay. Anyway, so you guys can go and study if you want to have a study group. Okay, I can see what's going on there anytime. It notifies me when y'all are in there, so it kind of looks good if you're going to go study. Anyway, again, I'll put the link, the invitation for y'all's office. I have a separate room set up for my stats class. So anyway, view.com, but yeah, I'm just going to write this too. So posting in general forum after the webinar. All right, so I'm writing this also for people who are coming to this after in the recording too. After webinar. Okay. So let's kind of talk about what are systems of linear equations. Okay. So what they are, okay, and if we talk about them graphically first, okay, let me get that out of here. If we look at two equations, so far we've learned to graph. Hopefully you guys are getting pretty good at graphing a line. Okay, so this is all about that. Remember, we're still looking at linear. If the word linear is coming before equation, it means it's still straight lines that we're dealing with. Okay, so what you guys have been doing is kind of taking the points. Come back, Eliana. Taking points, plotting them. You've been finding points using XY charts or whatnot, or even using your slope to graph a straight line. Okay, and just for example here, okay, and I'll try to do this freehand so it's a little quicker. So I'll call this line 1, okay, and I will call maybe another line over here line 2. Okay, notice that these two lines have a point that they have in common. It's this point of intersection, okay? Okay, so this point of intersection would be, this would make the statement of line 1, the equation associated with line 1 would be true if I plugged x and y in. But then also if I plug this x and y into the equation for the other line, it would also be true. So this is a solution for both lines, therefore it's a solution for the system. So this would be what the xy coordinate you're looking for when you go to solve. Okay, so let me put that. Okay, so the point of intersection, if it exists, okay, the point where the lines intersect. Okay, I'm coming to the question box, is the solution for the system, if it has one. Solution for the system of equations, if it exists. Let me see what this question's here. Okay, hey, I'm glad. I thought you laughed. Oh wait. Oh, okay, guys. So okay. Now let me kind of go through what I have here on the board here. I kind of got some notes out that I thought you guys would like. Okay. Let's see. I know I can like make my screen bigger, but that's okay. All right. So here we are. Let's take a look at this. Okay, a solution can be 3 types, okay? So we can have one solution like I just drew graphically. I just kind of drew that for you. So right here, there. We can have one solution where we have the 2 lines that intersect at one point, right? The infinite solution would be what? Would be 2 collinear lines. So here's line 1. I'm right underneath the word infinite solution. And then we graph the second line right on top of it, so they share every point. That would mean infinite number of solutions. Every point on the line is a solution to the system. And then the third scenario graphically would look like this, where we have no intersection at all. Okay, so here's my graphing area. No intersection looks like this, 2 maybe parallel lines. Right? They have to be parallel, how else can they never intersect? So these 2 lines never touch, parallel lines. That would be no solution, no shared points. Okay? So again, if the graphs intersect at one point, that's that single x and y solution that you're looking for. That ordered pair is the solution. Okay? So, by the way, we call that independent. Okay? I need to put a space in there, but independent solution, okay? Or let's see, we call the equations independent. Can't stand it. I have to fix this, so sadly. Go back. Okay, there. Thank you. Okay, and then, okay, if the graph of the equations coincides, that means collinear. If they graph one on top of the other, all the points are solutions. Okay, we have an infinite number of solutions in that case, and we call that dependent. Okay, and so let me see where my highlighter is. So we call that dependent. That's here. This was something that I had a lot of questions on yesterday. Okay, if the graphs of the equations are parallel, of course, no solutions, right? Of course, parallel lines will never intersect, right? Okay, we call that inconsistent. Okay, I have an illustration below with that, with all this, so it's going to come together. If it has, we say if it has at least one solution, okay, so look, let's come here, one solution or infinitely many solutions. So if it has solutions, then it's consistent. There's your word, consistent. Okay, no solution, that's your parallel lines, it's inconsistent. Okay? Okay, that's the terminology you're dealing with, okay? Here's what that looks like, okay? Notice consistent and independent. So the equations cannot be simplified to the same equation. In other words, they're 2 totally different equations, and they intersect at one point, one solution, right? So there you have your consistent and independent, okay? Okay, notice exactly one solution is kind of lightly written down there. Okay, consistent and dependent, that's your collinear, all the points are in common, okay? So they share the same points, infinitely many solutions, every point along the line, okay? And then inconsistent, that's no solution, correct? And that would be my parallel lines, okay? All right. So, excuse me, let me kind of come down here. So what type of solution would this be? Can y'all tell me? We have one solution at the point 5, 4 for these two lines. Can someone tell me what type of solution is this? First off, the two, let's see who's got me. All right. Correct. Independent. Very good, y'all. And would it be consistent or inconsistent? Good job. Consistent. Wonderful. Independent, consistent. You're going to have some things like that in your homework. Okay, so just kind of keep that in mind. Good job. Okay, let's see. I'm going to, let me make this back to normal size. Okay, I'm going to go down to where I have some examples that we can try. Okay, and I kind of just want to show you guys how to go about solving some of these. I'm looking at these practice questions down here. These are pretty, they line up pretty well with the types of problems you're going to see in your homework. So I'm going to take A first, okay, and we're going to just solve them, and then we'll say dependent or independent, consistent and consistent. So I'm going to take the equations in part A, okay, and my directions are going to read solve. So let's practice this. Okay, so example, solve. I'm going to make some room to the right of this too. And we'll say, we can say solve the system of linear equations. And last time I told you guys this is my shorthand. EQN is the shorthand for equations. Okay, so I have 2x plus 3y is equal to 4, and x minus 5y is equal to negative 11. All right. So let me make some room to the right there. Scoot us over. All right. What I like to do, you guys, is I like to put like a little superscript of 1 right here just to label the first equation 1 and the second equation 2, especially when I'm lecturing on this topic, because it keeps us organized. It'll help you kind of keep the two equations sorted out. So on this type, what I have a situation where I have kind of x is already by itself. It would be very simple for me to take the second equation and solve it for x and use substitution. So that's what I want to do first. I'm going to first work on this one, and I'm going to take equation 2 and I'm just going to get x by itself on one side. Okay, so let's do that. Okay, so what I'm going to do is kind of take equation 2 over one step. All right, and I'm going to remind myself that this is equation 2. It's going to look a little different, but it's the same equation, right? So I'm going to actually add 5y to both sides in an effort to get x by itself. Excuse me. So I'll have 5y minus 11. Okay? So what I can do here is I can take this new version of equation 2 into equation 1. Okay? So now I can use substitution, okay? I'm going to make a little note. All right. Now I'm going to use substitution. And let's see. And plugging, let's see. Plugging the, okay, equation 2 into equation 1. Let's see, we're looking for x, right? Because we have x is equal to 5y minus 11, okay? See that we have this. I'm going to come back. Let me rewrite equation 1 down here, okay? So here's 1. I'm going to rewrite it. 2x plus 3y equal to 4. Because I have that, everywhere I see an x, okay, I'm going to plug in that other side of that equation, okay? What is my pen doing? Everywhere there's an x, I'm going to plug in 5y minus 11, okay? So here's what that'll look like. This is just substitution. And you guys work ahead of me. I'm kind of like giving you some time. If you want to work ahead, do it. It's awesome. Everywhere there's an x, I'm going to open a parenthesis big enough to fit this guy in, okay? So I'm going to plop him right back in there in a sec, okay? So that's 2x plus 3y equal to 4. Okay, so we're going to go ahead and put this 5y minus 11 in for the x, okay? Right? Are there any questions so far? Now I'm going to go ahead and distribute the 2. I was telling one of you guys yesterday, every time you distribute, get used to hearing distribute and then combine like terms right after. Get used to those two things being together. So we distribute, then we always check to see if we can combine like terms after you distribute anything from here on out. Okay, so let's distribute that 2. Okay, thoroughly, right? 2 times 5y is going to be 10y. And of course, 2 times negative 11 minus 22 plus 3y equal to 4. We've distributed, now we need to combine like terms, right? We have the 10y plus 3y. 13y, okay, minus 22 is equal to 4. Okay, now I need to get y, I need to solve for y. What the whole purpose of this, the whole purpose of from here on down, was to substitute in to the other equation so that I have only one variable left in my equation and I can solve for that one, right? That we can do. We can solve for if there's one variable in an equation that's unknown. Okay, 2 variables, we can't, just like they are given to us up top, we can't really solve for that right up top at first. We had to do a little manipulating like you see with the substitution. So let's get y by itself. Let's keep going. Okay, just kind of wanted to kind of remind you the whole point of that. So let's add 22, right? Goes away here, and we have 13y is equal to what? 26. Divide by 13. Long story short, y is going to be 2. Okay, so are we done? No, right? We're only halfway finished, right? We need to go back up to, and you can go back up to the one where you have x solved already. So we can take this guy, we can take what we just found, y is equal to 2, into the second version here of equation 2. We can kind of come back here and replug. We want to substitute that back in, okay? So we're going to take that into equation 2 where we had solved for it, and it was x equal to 5y minus 11. You can put it into the original version of that. That's fine, but these are equivalent, right? And we already have x isolated, so we might as well use that. So now we have x is equal to 5, and instead of y, I'm going to put my 2, right, because we already found y. Okay, minus 11, and now we have 10 minus 11, which is negative 1. Okay, and so actually let me keep format. So we'll have x is equal to negative 1. Okay, and so let me go ahead and show you, though. This doesn't really illustrate what the point really is, or what the solution truly looks like. Our solution, okay, let's see. So, okay, 3 little dots in a triangle means therefore, right? Therefore, the point, right? The point or the coordinates at xy, right? Negative 1, 2 is the solution to this system. The solution point, meaning what? This is where those two lines will intersect, etc., right? It's the solution to the system. I'm not going to write the whole system again. Okay, so what type of solution is this? Let's go back and kind of look at that illustration I had above, just to kind of remind you what I'm talking about. Let's see, where is that? Yeah, so this would be which one of these? If we look, which one of these was that? This would be consistent and independent, right? Okay, because it has one single point of solution, right? So let's write that too, just to kind of, okay. Another therefore would be this, right? A single point, single solution point, independent and consistent. That's supposed to be an N. Independent and consistent. Or E-N-T. Okay. All right, so let me kind of go on with that. Let's see what else I wanted to tell you guys. We can graph these. Let's go ahead and graph some too. Let me find a good example for that. A graphical example. Let's see which of these I used. Let's see. Do I want to use that? No, I don't. Let's take, well, we can graph these. Let's go ahead and look at these same 2 points graphically, okay? Might as well. Okay, so that was the algebraic version of that, right? I'm going to go ahead and do this graphically, okay? So right here, okay, so this example is just going to be solve it graphically. Graphically. Some of you may need some help still, or another example of how to graph linear equations, so I kind of do want to go through this with you. Okay. All right, so to solve these graphically, we're going to just graph one equation at a time in the same space. So again, I'm going to kind of do this. I'm going to label one. Equation 1 is what? 2x plus 3y is equal to 4. And equation 2 is x minus 5y equal to negative 11. Okay. So, two things you can do. We can leave it in standard form and just kind of get, oh wait, that should be a 3y there, by the way. Let me fix that. 2x plus 3y. Okay. I mean, if the numbers work out nicely, you could use your x and y intercept, but they're not very pretty in these. So we're going to just pick x's. We're going to make an xy chart for each one. Okay. So here was what I'm going to do. First of all, actually, I'm going to give us some space here. Oh, no, come back. We don't want to take off without that one. Okay. But to take off with our equation. Okay. So let me go back up. All right, give us some room. Okay. Now what I'm going to do is make us a little graphing area here too. Okay. So by the way, you guys, don't forget that I have the graphing printables for you guys. Okay. Y'all are using that. Some of you are using it. I'd love for y'all to use it for your homework. I have some with like 8 on each page. If you want me to try to find or create some that have few more places on each page so you don't have to use so much paper. It's up to you. I can kind of figure that out for you and give you some more printable options if you'd like. But I think you have enough. You can always use that one full page. That's the one that says full page, is like regular graphing paper that you buy at the store. And you could always section that off into more if you need it. Okay. Are y'all with me? Let's see. Let me check the question box, see what we got. Okay, just to kind of, before I go too far. Okay, y'all are with me then. Okay. Alrighty. Close that. Okay, let's take equation 1, okay? So we're going to just work on graphing equation 1. Okay, so first we're going to work on graphing the line equation 1. My black pen. Okay, so 2x plus 3y is equal to 4. Okay, so what you could do, this would be nice and simple to do. We can solve for y and then pick x's after that. If you want to do that, I think it's kind of nice to do that. So let's do that. It's good practice to get into slope-intercept form anyway. Okay, so I'm going to divide by 3. Y is going to be negative 2/3 x, right, plus 4/3. Okay, did I forget anything? Looks good. Correct me if I make silly mistakes. Got the blood sugar getting low over here. So, okay, here's what we talked about last time. Okay, we're going to go ahead and pick x's and y's that are more appropriate for this. We may actually, let's see. I think I would like to, let's see, choose carefully, of course. We're going to be okay. We may have to do a third here and there. It's not hard to do, so we'll be all right. So if I choose 0 for x, by the way, I'm going to put that down because I may choose a negative value in a minute. I'm going to choose a 0. I'm going to choose something that'll cancel this 3 out in the denominator, okay? So it won't do anything for my 4/3 though, but that's okay. Okay, so here's what I can do. I'm going to choose, well, I could choose, let's see. Help me out if you want. I'm trying to figure a good one out for us. Oh, I can choose -1 and 1, and then we'll have something that'll go. Let's try -1 and 1. I'm not going to choose a 3, because, and you'll see why in a minute. Let's go ahead and plug in -1, okay? You guys are probably like, what is she worried about? What is she doing? I'm trying to choose x's wisely, and again, it's not a perfect science. It is a perfect science if you are a calculator, but if we're human, we have to kind of plug and chug here and there and get it right. Takes a little practice. It's something to do. Let's plug in -1. Okay, so x equal to -1. So this is my scratch work, right? Negative 2/3 in parentheses -1 for x plus 4/3. Okay, so now I'm going to have what? I'm going to have -2 times -1, which is positive 2/3, right? Plus 4/3. Okay, and here's why I did that. I kept -1 instead of a 3. I'll have 6/3, which is going to be what? 2. Nice. So you can pick values that'll work out as into like integers, which are nicer to plot than other things. So it can work out. So let's do 0. 0 is going to leave us with a 4/3 there. Okay, if I put in a 0, we'll have 4/3, right? Okay, because that's our y-intercept. I don't think I need to do that one. Let's go ahead and plug in 1. Give you another little look at plugging in. Y is equal to, okay, we're going to put -2/3 times the 1 plus the 4/3. Okay, so now we'll have what? -2/3. Okay, -2/3 plus 4/3. And so now we have what? 2/3. See? So can't get away from it completely, okay? All right. So let's see. What value could I have chosen, you guys, to make maybe something else that would have been a whole number? Does anybody have one? You guys want to take a shot? Give me an x, and I'll plug it in. Try something. Does anybody want to try? Anybody? Anybody want to give it a shot? No? Okay. All right. I'll just plot these points, okay? So let me kind of just make my scaling. These are whole steps, okay? So like 1, -1, -2, -1, 2. Not perfect. I should have put graph paper up, but it's okay. We'll be all right. I'll live. You'll live too. All right. And it should be enough. Looks pretty decent. This is what you do if you don't have graph paper available to you, but you guys all do for your homework because I made it printable online too. So if you do that, you want to do your scaling first, like I just did. Then you go to do your points. You don't want to go plot your points first and then do your scaling because it's going to be totally unorganized. So first point, -1. So 1 to the left. We start always where? We start at that origin, right? There's my origin. I just put a little tiny red dot on that. Okay, and I'm going to plot this whole line right here. Is going to be in black. So -1 to the left and then up 2. So my first point's about right here. Okay, so that's -1, 2. 0 left to right, up 4/3. And what is 4/3, by the way? That's going to be, this is where you can use mixed numbers or decimals, right? This will be 1 and 1/3. So 0 left to right, up 1 and 1/3. That's going to be about right here on the axis, right? On the y-axis. The y-intercept. So that's 0, 4/3. Okay? Now 1 to the right, up 2/3. And 2/3 is going to be, let's do some smaller tick marks here, about right here. Okay? Oop. Okay. Yes, and my pen thinks I'm trying to scratch it out. Sorry. Okay. Here we go. Okay. Let's make sure I didn't like totally mess it up. Okay. So that's 1, 2/3. And it's working out. The reason I chose 3 instead of 2 points, oops, let me see. Chose 3 points instead of 2, not quite hitting that there, am I? Is because we want to, there we go. This is going to give us a better idea of whether it's going to help us discover mistakes if we make any error, okay? So if I had gotten, like, say, a sign rule or something wrong or made an error in my count, my numbers, I would have, like, a point that would make something not happen in the correct direction, right? So the fact that they're all lining up is kind of showing me I can keep moving on. I can keep going. So, by the way, this is, this would be line 1. Let's call this line 1, okay? I'm going to do this, line 1. For that, okay, and we'll just call this line 1 here. Okay, so let's go to line 2, all right? So we want to go to the second equation, x minus 5y equal to 11. Okay, and we're hoping at -1, what was that point we saw earlier? We solved earlier, and we got -1, 2. So we're hoping at -1, 2, which is one of the points that I got here. So we're doing good so far. All right. So let's go ahead and do, in blue, let me get my blue. I'm going to kind of scroll down a bit. Actually, I guess I'll do that down here, watch. And we'll do my scratch work for that one down here. Here's equation 2. I'm down at the bottom right of your screen. So this, now I'm trying to graph x minus 5y is equal to -11. Okay, and so let's get our correct color now. Okay, so before I could do the graph, I'm going to go ahead and just do the plugging and chugging here. Let's make a little XY chart. I'll make it right here, XY. Okay, and I'm going to go ahead and just choose similar numbers. I had -1, 0, and 1. Okay, -1, 0, 1. Always wonderful. 3 most simple, easy numbers to deal with. I'd go here first. Choose these numbers if you can at all times, unless you have to go to multiples of 3, for example, or something to that effect. Now let's go ahead and solve this equation for y, just to kind of, again, get some more practice with that. So we'll have what? -5y is equal to, and we're subtracting x from both sides. So subtract x and -11. Now I'm going to divide by -5 on both sides. Doing that, I should have y is equal to negative, and we'll have 1/5 x. You could also have -x/5. Either way, but this is fine as well. And then -11/5. Okay? You have to be careful there, okay? Don't forget you're dividing the whole right side. Everything gets divided by that number, okay? So if you had a step that you would probably have in there would look like this, we may wind up with, and let me scoot over to the right a little for you. Between these two blue steps I have here, you could have ended up with something like this, negative x minus 11 over 5. If you have that, from this step, you would put each number in the numerator over 5. That's where this comes from, okay? Okay, so this is what is not written, in case anyone's like wondering how I got to that end with this slope-intercept form. Okay, let's plug in a -1 and see what we get, okay? So first off, let me kind of separate this out and say, okay, first now when x is -1, here's what I get. Y is equal to -1/5. Plug in your -1, okay? Yes, it's fractions. We can deal with it, though. It'll be fine. Okay? So we have what? Now, positive 1/5, right? Positive 1/5 minus 11/5. Okay, we have the common denominator. So now we have 1 minus 11 over 5, or what? -10/5. This actually works out very nicely to -2. Look at that. Right there, I have my solution point. Now let's get a 0 and a 1 and quickly and we'll be done. Of course, we plug a 0 in for x, and look, here's what I want you to do. Put your thumb up. Everybody, like, put thumbs up and you don't have to touch your screen, but cover up what I'm about to highlight with your thumb. Okay, close one eye and look at the screen. Okay, I'm highlighting this -1/5 x. Now put your thumb in front of it so all you see is x equal to -11/5. Okay, you're hiding that x term. Hide the highlighted thing I just did. Okay, so you're putting your thumb up and you're putting it between your vision and the screen, right? And you're just covering up the highlighted thing I just highlighted, right? That's similar to plugging a 0 in for x, okay? Okay, so there you go. That's kind of one way to do that if you're looking for your y-intercept. So if we plug a 0 in for x, this whole term goes away, right? And we have -11/5 left, okay? So anyway, now let's plug a 1 in. All right, x is 1. Okay, so now x is +1. Next scratch work looks like this. Y is equal to -1/5, open parentheses, put a 1. Okay, minus 11/5. Everybody's with me? I know this can get like tedious, but stick with me, okay? We're almost finished. You with me, Nancy? Okay, all right, just making sure. Okay, so we have what? -1/5. Yep, -1/5 minus 11/5. Okay, so this would be -12/5. Okay, so yeah, I did that kind of quick, so make sure if let me know if y'all find a mistake. I think we're doing okay so far. Okay, so let me get this mixed number here. Okay, 11/5, 5 goes into 11 twice. What's left over is 1/5, right? So -2 and 1/5. And then 12/5, 5 goes into 12 twice, leaving 2, -2 and 2/5. I think that looks good, right? Yeah, okay. If I have messed up, please let me know. It looks kind of funny to me, but I think we're okay. So the first point I'm going to plot is that -1. Oh, look, the 2, why did I put a -2 there? It should be positive. You're right. This should be a +2. What did I do? Right here. Let me go check that, okay? Excuse me. Yeah, we should have a +2 there. You're right. Is that what you're talking about, Nancy? Let me see. Okay, let me just go back. Oh, you're right. Is that what you're, let's see. Did I write it? I might have written it wrong. Yeah, let me see. Let me go and check my copying work. Let's make, all right, hold on. Yeah, x minus 5y was negative 11. Okay, so let me check my my slope intercept here. So if I, yeah, you know what I did? I divided by negative 5, and there's a negative 11. So this first one would be positive. Is that what you're saying? Is that what you're getting at? Yeah. Yeah, you're right. So I have my first term should be positive. Okay, y'all. So I'm divided, actually they both should be positive. So I'm dividing by a negative. So look, in the, these guys should be positive. Okay? So there you go. So I need to go back here and do this. So we will have a negative 1, so this should be positive, this should be positive. Sorry, guys. Y'all probably, maybe you probably saw it already and you're fixing it already. So that'll make this positive. I'm plugging a negative 1, making this negative. So I'll have positive 10/5, right? Which is what? Positive 2. Okay, beautiful. Thank you so much. Good eye. That's very good. That's not. This is actually good practice for sign rules. Believe it or not, I'm not going to really fuss about that too much. Here's what I'm going to do. I'm going here. I'm going to do this, 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 and this, and I'm going to go back through and apply the correct sign rule. Simple as that. It's just something that needs to be done. Okay? So we have positive 1/5. X is 1, so that's good. Okay, 11/5. So still, it's going to be 1/5 plus 11/5. In this case, positive 12/5. Okay? So not much really changed on that. You know, we still have what we have. Okay, and also, let me come here and say that my 11/5. Okay, oh boy, let me go ahead and put that back. Here's what I'll do. Okay, come on back to me, Karen. Let's see, what did I take out here? All right, so I'm going to go ahead and put this like that. Make sure I have that. Hold on. All right, you guys can start plotting too, by the way. Oh, I see. Let me put my little plus 2 1/5 plus positives. I could just scratch it out. That's right. This one won't scratch out too much. Some of them want to scratch out and some of them don't. Okay, so let's scroll up. Let me scroll you up and we'll put these points in. Okay, at any rate, negative 1, right? I'll see what I did too. My little tick marks went kaput. Negative 1, okay, these are my tick marks. Negative 1, positive 2, again, is up here. Let me get my blue for this. This is this point, this line, right? Line 2 is blue. Okay, so 0 left to right, then 2 and 1/5. So 1, 2, and then 1/5 is about right here. And that's a y-intercept, so it's going to, the point we're plotting is going to be on the axis there. Okay, and then positive 1, and let me put that fraction board back on my 12/5. 2 and 2/5. Positive 1, 2 and 2/5. So 1, 2. So we were at 1/5. Here's 2/5 would be right above that. Well, let's see. Okay, let me check this really quickly to make sure. Did I mess something up, guys? Help me out. Come on, I want to get off this problem here. Let's see. 1 is going to give me 1/5. Back me up, people. Help me out. Okay, so we have that. Remember, it's not to scale. That's right. Let's see. 1/5. Give me a sec. Okay, no, that's fine. 12/5. All right, and so my negative 1 is what I'm plugging in here. Negative 1/5 plus 11/5. It's going to be 10/5. All right, so I don't see any numbers that are messed up or anything, so I think we should be okay. All right. All right, it's just right above is what it is. It's just kind of close. And I'm not to scale. I keep forgetting that too. You know what it is? It's not to scale. How about that? So this one should be kind of, the numbers are correct, you guys. It's because I didn't draw it to scale. So this one should actually be a little lower. Okay, so there's line 2. Okay, so lesson learned. This is a good reason why you want to use graphing paper, especially if you're plotting fractions. What just happened to me, just there, my little moment of having to go back and check, which is normal. You got to go back and check sometimes. Something's not sitting right with you. That's why you have these skills. That's the whole point. I mean, when you get a job involving mathematics, especially in medical, you're not going to be given a perfect set of equations to solve. If something hits you in the gut with a patient's medicine, when maybe you have to do calculations on how much medicine to give them, right? Dosage calculations. I've coached a lot of nursing students on that. If something doesn't sit right in your gut, you'd better go back and do your calculations again, right? You need to go and check. That's the part of this. This is why you should be good at doing this. And it's okay to have to go back and check your work. I want you guys to do that. At any rate, now you can see where these two lines do intersect at this point of intersection, which we found earlier. Okay, so graphically, that's how you would solve these. Okay. Now, graphically, again, I just want to review this because I'm about to run out of time and I have to do another. I would like to kind of touch on what's going to open up for this coming week. Okay, just to kind of give you an idea of what's coming up and look at that other problem for you. Question for the homework. So when it asks us to solve in graphic, I'm reading someone's question, by the way. When it asks us to solve in graph equations, oh yes, thank you, Nancy. That's what I wanted to do. Yes, let me look at one. How about if I look at one of those, okay? I would be happy to do one of those for you. Okay, let me get that pulled up. That's a great idea. That's what I'll look at real quick because that was one that I looked at with some other students. I really did want to look at that with you guys today. Thank you for saying that. You talking about this other homework. All right, let me go back to that one. Okay, I'm pulling that up right now. Okay, let me kind of go here, get rid of that. Let me give us some room. Totally forgot what I was saying though. Okay, you want me to go there instead of wherever I was going with that? That's fine. I think y'all all kind of probably have consensus on that. Let's take a look at that because we're going to look at those problems. Okay, those problems. Let me pull that one up. Okay, and if I don't do exactly that, I'll do one just like it. Okay, so what I'm looking at right now is, I'm going to take a look at, say, number 20 here, okay? Or now I'll look at 19. That's pretty simple, too. Actually, 20. Let me stick with 20, okay? I'm going to set up that graphing area that they're concerned with in 20, okay? Just to kind of give you the idea, okay? And it's saying show your axes spanning from -5, okay? So they're wanting to show -5 through 7 on the x-axis, right? Okay, and then they're wanting to show -6 through 6 on the y-axis. Okay, let's kind of look at that. Does any of you have graphing calculators like a TI-83 or 84? If you've ever seen those, if you ever dealt with one of those, you can set up your screen to display, right, your calculator screen to display between two x values and two y values. This is similar to that. What they're saying is the minimum value showing, minimum of x would be -5, okay? And they're saying the maximum value that they want to see in your graph would be a 7. They're telling you how to scale your axes, okay? So what am I going to do here, okay? Let me go ahead and just bring up some generic. I'm going to wind up trimming away some of what the axis I've just drawn. Well, I tell you what, let me go ahead and do this now. There we go. So let me get rid of those. Let me make it prettier. Okay, let's go back graph paper. Okay, so I'm going to kind of told you guys I should have used graph paper last time. I could have done this easily. Sorry. Okay, so now look, I'm going to trim away some of these axes in a sec, but I want to show you what's going on here. Now, let me get a pen. Okay, so -5, right? We want to go from -5 through 7. So -5, -1, -2, -3, -4, -5. So in other words, they only want to see to the right of -5, right? And then on the right side, the maximum x value, 1, 2, 3, 4, 5, 6, 7, right? So they only want to see to the left of 7 there, okay? So that inside those two dotted lines, that's what they want to see for the x's, okay? And now for the y-axis, you want to say, okay, from -6 to 6. This is important to kind of at least understand what it's doing, okay? Because we're going to be talking about what's called the domain and the range soon. And this has, knowing how to visualize what I'm doing here on the axis is going to be extremely helpful to you when you're asked to find the domain and range. So try to get this. I'm just saying, where do we want to picture this, you know, the graph area? This is what part of the graph I want to see. So that's -6, right? So I'm going to do a dotted line there, okay? Dotted line. And then to +6 is going to be 1, 2, 3, 4, 5, 6, right? So inside the little square I just made, right? This is whatever the graph ends up looking like. This is the part of the graph that, I guess on your calculator it's called your viewing area. This is what they are talking about, okay? So this is what they're wanting to see. Okay, so it says show axis spanning from -5 to 7 on the x-axis, so that's in this highlighted blue area, and -6 to 6 on the y-axis. This is the region defined by the set. So now what you could do is you would go and graph those problems, okay? And so what I'll do is I'll graph y is greater than or equal to 1 because I'm running out of time. So now you have these different problems. Well, I guess I'll do as much as I can, but probably can't do them all. I'm going to try. Okay, guys? So 4y minus 3x less than 12. 2x plus y, let's see, less than 0. And then you have y is greater than or equal to 1. Okay? So anyway, y is greater than or equal to 1. That's simple. We want to graph y is equal to 1. Okay, where's y equal to 1, right? Y is equal to 1 here, right? Okay, now notice I'm putting a dotted line, but it's really going to be a filled in line because it's or equal to. I'm just trying to put exactly like where it is. Because it's or equal to, we put a solid line. Okay, for our boundary line, right? We want to fill that in, solid. Okay, and look, let me put this, that this is the line y is equal to 1. But y greater than or equal to 1 is where? And I'm going to use like just some red lines here. Is above, right? And what they're trying to say is only show it in this area. This is what they're wanting to see. So I'm going to use red diagonal stripes for this one. Okay, and let's see, this is homework. So and even though I'm using this as a bonus, I'm still not going to do the rest because, to be fair, I'm going to let you guys finish it. Okay, you can do this. Okay, so all you're going to do is first you're going to graph the associated line. Okay, so you'll act like, let's see, let me come over here. So to do this graphical part, okay, first graph the associated lines. Okay, in other words, instead of inequalities, put an equal sign and just graph that. Equations, I should say. For example, 4y minus 3x is equal to 12. And of course, once you graph it, you're going to have a dotted line, right? Because it's less than. Okay, and we're going to do let me get my bearings here, okay. 2x plus y is equal to 0. And of course, that one's going to be a dotted line, correct? Because it's not or equal to. And of course, what we've already done, we said we graphed y is equal to 1. That one was solid because it was greater than or equal to. Okay, these are just less than and less than. Okay, so if the endpoints solutions wouldn't be included, right? You don't include, you exclude them by drawing a dotted line, graphing a dotted line, as opposed to the solid, which would include your end point or your boundary. Okay, let me see what we got. Question box is here. Okay, coming to you. I'm trying to open my question box. Okay, let's see. In the homework problem 1, do we just graph y is equal to -3? Problem 1. Okay, hold on a sec. Let's see. Give me a second. Okay, so that's the next one. Let me get to 8 and look at it. I gotta go back into lecture 8. On lecture 8, you're talking about lecture 8, number 1, correct? Okay. Solve the system of equations graphing on x and y axes spanning from -6 to 6. So yeah, okay. So on that one, that's kind of what they're doing. They're just saying they want to see both the x's and the y axes spanning from -6 through 6. So do the same thing. It's going to be a square. And you're asking me, do we just graph y equal to -3? Okay, you have to do both, or do I have to find x values for it to? Okay, well, you don't have to, because y equal to -3 we know is a horizontal line, even with the -3, right? So let me come over here and show you. Okay, let me scroll down here a little bit. This is probably what I have time for here, and I have to kind of answer questions. Like I said, I'm going to be in my view office, okay? I'm going to post that link afterwards. I'll bring you guys a link into the general forum, and I'll be able to answer more questions in the office. But we know, look, I'm going to kind of separate us off here. Y equal to -3 is what? We have horizontal and vertical lines discussed in the previous lecture last time. You find -3, 1, 2, 3 down, right? And you draw a a horizontal line. This is the graph of y is equal to -3, right? Should have done it in another color. Right here, right? Okay? That is that. So really, you don't have to find points, but if you forget if it's horizontal or vertical, here's what you do. You can do a little XY chart and put in -3 a couple of times for y, because y is always going to be -3, and pick a 0 and a 1, because you're going to go 0 left or right, down 3. You're going to end up plotting points along this line, right? 1 to the right, down 3. You're going to go on this line with whatever you pick, because the y is always -3 for this equation. Okay, let me see. I got hands up. Okay, I'm putting all the hands down just to kind of be safe. I'm coming back to question box. I hope I am. Okay. Hopefully it answers your question, Stephanie. Did I help you out? Does that kind of help you? Okay, no problem. Yeah, oftentimes we make it harder than it has to be. My advice, you guys, keep it simple. You know, you can always make an XY chart. Sometimes it just may be a simple XY chart that you realize later you don't really need. So, no problem. Okay, anytime, you guys, you're very welcome. That's it for the webinar for today. I hope I've helped. And again, look for the view.com link. That is be my virtual office hours. I'm going to be in and out of my office, but from now until 3, I'm going to go grab some lunch, and it'll be on the general forum. I'll be around here, you know, just kind of waiting for somebody to show up. But anyway, I'm going to go post that right now. Hopefully you guys will start coming Tuesdays and Thursdays. That way you can get more help. You guys have access to me if you want to come. We can do administrative things if you have questions about grades, etc., etc. Those are my office hours, okay? And I'll be available to you guys pretty much most of the afternoons on Tuesdays and Thursdays. Of course, beyond that, I'll answer your emails, of course, as they come to me as I can, if whenever possible. But come and talk to me in my office. Come check it out. All right. Hope to see you there. Y'all have a great day. Talk to you soon. Bye-bye.